Hello inventors, welcome to the channel, and today finally we will release the new version of the MFS for K1 Max. I know, it's been a while since I promised you some upgrades that I've made on the K1 and K1C version, but it was for a good reason, because besides the fact that was a very busy year, I want to make sure that all the features that I had implemented on this version was stable and functioned very well. And of course, thinking about people that already bought the MFS and built it on their K1 Max printers, I tried to make the most effective changes on this version, trying to reduce as much as I can the number of pieces you will have to reprint to have those upgrades. So in this video, I will show you all those new features, including some new and better parts to use on both MFS. So if you are new here and you have no idea what is MFS, don't worry, stay tuned on this video and I will explain that to you and show you what these two projects are capable to do on your 3D printing life. Stay tuned and let's invent. The MFS project, or Multi-Filament System, or mod, or case, or dry box, doesn't matter how you prefer to call it, it's a system. Yes, it's a system. It actually contains the most basic concept of a system, that it's a bunch of components that has different functionalities, each one that work together to realize a common global function to resolve a problem or to execute something. So this is a system, and this is the MFS. The MFS is basically a case that you will put on the top of your printer. It can be a K1, K1C, or a K1 Max from Creality. It was designed specifically to work with those three printers, and it allows you to handle the filaments from the front of your printer. And it saves you from that terrible task of changing filaments and put the filaments on the back of the printer, or move the printer, or having to have the printer in the middle of your room. So the case will allow you to handle the filaments from the front of the printer, and even better, because even on the default method to change the filament on K1 and K1 Max, you basically have to use two hands to push the filament into the PTFE on the back of the printer, and then unlock the extruder, put the filament inside, lock the extruder, and then click on extrude, and then wait the printer. So this mod will improve your usability, because you can put the filament here inside, push the filament inside the filament guide, and extrude using one hand, and without the need to unlock the extruder of K1 and K1 Max. Besides that, the main function of the MFS project is to keep your filament dried without having any kind of extra device to consume more electricity. So using the heat generated by the hotbed, this device provides an easy and natural way to make the hot air flow through your filament spools and carry the humidity with it. And the better part of this project is it's a project. It's not a product. You don't have to buy the project entire and pay for shipping and things like that. You just buy the project, print by yourself, and then you can assemble it on your house. And even better, if you buy one license, you can build units of MFS for all your K1 printers or K1 Max and enjoy the benefits of having your filaments dry during all the period you are printing and having your filaments inside. So some people had asked about the efficiency of MFS, talking about the temperature inside the chamber and things like that. So I will explain a very basic principle here. So when you are printing ABS on your 3D printer, you will have to have the hotbed temperature at 100 degrees Celsius. So having the bed at that temperature, after a couple minutes, the chamber of your printer will heat something about 55 and 60 degrees Celsius, and you will have that stable temperature for a long time while you're printing. So 55 and 60 degrees It's the perfect temperature to dry your ABS filaments. So you can confirm that watching the recommended temperature to dry using the common dry box, the electric dry box you can buy on AliExpress or Amazon or eBay. So that is the ideal temperature to do not melt your filament while you are drying it and to reduce the amount of humidity inside the filament. You have the same effect and the same proportion for other kind of filaments. Like PETG, you will use the hot bed at 70 degrees Celsius, which will give you a temperature inside the chamber between 45 and 55 Celsius. So that is the ideal temperature to dry PETG. And while you are printing PLA, you will use the temperature about 55 degrees Celsius on the hotbed, which will give you something about 35 and 45 degrees Celsius inside the chamber, which is the perfect temperature to dry your PLAs. So not all PLAs need to be dried. There are some brands on the market that don't use EVA and other kind of moisture absorbing components as additives on PLA filaments. So those kind of filaments don't suffer too much with moisture. On other hands, filaments like the Creality PLA, the Hyper PLA, used to absorb a lot of moisture. So you can see a test that I've made last year here on the channel. So I will leave the link at the description so you can go there and see a real-time test where I used the Hyper PLA inside the MFS and start printing with the Hyper PLA with a high rate of moisture. And while I was printing, you can see gradually the moisture leaving the filament and improving the quality of the print. So having that said, that you can use the MFS to make your life easier handling the filament from the front of a printer. You can dry the filament, and especially you can keep the filament dry during all the period you are printing. It's very, very important to say that if you live in a geographic area where you have a very, very low humidity on the air, you will probably not need the MFS, or you will probably be one of that persons that say that moisture on filaments, it's a kind of myth, and then people that believe on that doesn't make sense and blah, blah, blah. But the reality is that people that lives on regions that has a very, very high humidity, they know how that is so annoying and so problematic for 3D printing. Especially me, I live in Brazil in a city called Curitiba, and in the most part of the year, we have humidity between 90 and 98% here. So having that high humidity on the air makes the 3D printing a real challenge, a real fight against the humidity while you're printing. So just to have an idea, trying to print in a day with 95% of humidity means start printing at 8 a.m. and having the filament completely dried, and about 2 p.m. having the filament a completely mess and a completely catastrophe on your 3D prints. So not having a device like MFS in a city like Curitiba means that I should have a lot of dry boxes working on the side of all my printers, and that will cost a lot of money on electricity spends. And having the MFS, I don't have to spend money with electricity. I just put the filaments here, and I can have 3 filament spools at the version of K1 and K1C. And now in the new version for K1 Max, we can have up to 4 filament spools at the same time, what means that I can print 1 filament and dry other 3 filament spools at the same time while I'm using one of them. So one of the biggest questions asked during this year since we released these 2 projects was, is this project something that can be used to print multicolor or multi-material, change the filament automatically and things like that? So the answer is no. The project MFS, it's a static dry box that can use the heat of your printer, but it cannot change your filament automatically, and it cannot change the filament color during the printing. At least not by itself, but the K1C version have been thought and designed thinking about this kind of integration. So the filament get out of the MFS through the top of the MFS and passing through the back of the device and getting into the printer. So you have all the PTFE tubes back here, and you can pass this PTFE tubes through any automatic device you can integrate with the MFS. And the new version of MFS for K1 Max now has the same feature. Now it has the filaments getting out through the top and passing through the outside of the device using a filament hub at the backside, where you can replace this hub by an MMU from Prusa or a ERCF from Voron project or a 3D Chameleon, that are all open source projects you can buy, you can build, and you can integrate with the MFS project. So we don't provide support for this kind of integrations because I didn't have the opportunity to try this integration yet, but I know that are a lot of people on open source communities trying to integrate and creating this kind of integrations, especially because this is a project that you have access to the STL files, and on the Pro version, you have access to the step files and the special manual with all the specifications of each one of the parts that compose this project. So you can modify, you can adapt, you can expand the functionalities, because buying this project, you have access to all the source files that you can use to modify and adapt to your needs. And by the way, talking about the kind of licenses, it's important to understand what is the difference between those licenses. So we have two basic licenses. One is the personal license, and the other one is the Pro license. On the personal license, you have access to the STL files, to a manual teaching you step by step how to print, how to build the project, how to cut the acrylic sheets. And this manual, it's a very, very, very detailed manual, step by step, showing you with images and details and with the entire list of hardwares you will need to build and assemble this project. And to complement that, you have access to a video tutorial where I will show you the assembly of these two projects one more time, step by step, showing you and giving you some tips to make your life easier while you're printing and building this project. On the other hand, in the Pro version of the license for MFS, you have access to all the files you have on the personal license, plus you have the step files, the DWG files that allows you to cut the acrylic sheets using a laser machine, and you have access to the Pro manual. That is a full list of components of each project with all the measurement specifications, so you can build new extensions for it, or you can modify knowing exactly what is the size of each corner on each one of the parts that are included on this project. One of the most weighted change on the K1 Max version is the rising of the MFS. So in the first version, the aluminum pipe used at the bottom of the MFS used to scratch the PTFE tube right at the entering of the extruder. So we raised the MFS 2 centimeters to make sure that the PTFE will not hit the aluminum pipe, and even to give you a little bit of more freedom when you are handling the PTFE tube at the top of the extruder on the K1 Max. One important feature we implement on the K1 and K1C version was the possibility of adding a foam tape at the border of each one of the doors, making this device a very, very well sealed device, allowing you to print ABS, ASA, and Triton without having to smell that strong smell, that stink that gets out of your printer while you are using this kind of material. So on the new version of the K1 Max, you have the same possibilities. We extend some tabs at the front of the MFS, at the top of the MFS, and even at the window on the top of the door here to allow you to use the foam tape and seal a little bit better the MFS. But here, an important thing about ASA and ABS and any other material that has a toxic fumes that can be released in your environment. Even considering that the K1 and K1C version, for example, has a better sealing of the K1 and K1C printers than the default lead you receive with your printer, it's not recommended that you use your printer printing this kind of material inside an enclosed environment, like an air-conditioned office or any other closed environment without a proper ventilation. So it's very, very important to say that these printers are not hermetically sealed. So it doesn't matter how you seal your MFS, your printer will have some natural bridge that will allow the fumes to get out through the door at the front and through the back. Especially if you have the K1 printer, for example, and you don't have the carbon filter at the back of your printer, that it's not a default component that came with K1 and came with K1C. But you must be aware that these fumes are not contained inside the printer, even using the default lead that has that huge hole at the back, or even because of the door of those printers. So be careful with your health when you are using those printers and printing this kind of material. Another question is the MFS an open source project? Yes, it's an open source project. If you buy it, you will receive all the files that you can modify, print, extend, and do whatever you want for your personal use. Because here on the channel, we depend on those projects and other projects we are developing to bring here to you to keep doing this job, keep working on it, creating projects, reviewing products, and things like that. So we need that revenue. We need to sell this project to keep doing our job. So it's an open source project for your personal use, but it's not free for redistribute. So please do not do that. Help us to keep doing our job here on the Inventors channel. Does this project comes with screws and aluminum pipe and acrylic sheet and things like that? No, we don't have the hardware parts to sell with the project. When you buy the project, you buy all the digital files and the entire list of hardware you will need to build and assemble this project. So, okay, Wesley, so how much I will expend building this project, how much I will need to buy all the hardwares. So based on the users' feedbacks, it depends on the country you are living, but it will cost between $60 and $80, okay? So it depends on the country you are living. And that price includes the MFS license. Okay, but Wesley, if the MFS will dry the filaments using the heat generated by the printer, can I leave the filament inside the MFS during the night? Yes, you can do that, especially because the filament can release the moisture faster than it can absorb if you consider the difference of temperatures. So when you heat the filament, the moisture will get out faster than the filament can absorb humidity at the environment temperature, at the normal temperature. So if you will not print with your printer for a while, for more than 6 or 8 hours, I recommend you to remove the filament from here, put on a bag with silica gel and store your filament properly, even to protect from dust and other kind of problems you can have having your filament exposed like this one, okay? So do I need to print this project using ABS or ASA or any other stronger material or material that are more resistant to high temperatures? No. All the versions I printed here on the garage, I've used PETG. And after more than 1 year using the MFS to print all kind of materials, I had absolutely no deterioration or deformation or any other kind of consequence just because I've used PETG. So I prefer PETG because it's easier to print, especially because the both projects has big parts that needs to be printed at the transversal position on the bed, and they can bend, they can rub depending on the material you're using. Even if we talk about ABS, there are a lot of different kind of ABS on the market with additive, no additive, good quality, bad quality. And if you are a beginner at the 3D printing world, probably you will have a nightmare trying to print big parts using ABS. Okay, so I recommend you to print using Apache unless you are a very experienced user. But honestly, I don't see any necessity of using ABS or ASA or Triton or any other complex material because Apache works very, very well. And by the way, the new version for K1C and K1 Max now has the 3MF file inside the package. That will help beginners to print the parts, especially the parts that use more space on the building plate. And depending on the slicer you're using, it's a little bit tricky to apply the supports and having the part well accommodate and fit the bed. So having that in mind, I've prepared a 3MF file with all the beds ready, with all the parts ready to be printed, with individual check to make sure that all the parts has the right support type, the right support proportion, measurement, and everything to make sure that you will be able to print the MFS projects in a very, very easy way. Talking about being easy. So another question was, Wesley, is it easy to build? Is it easy to print, to assembly, to use? Yes and no. Okay, the yes, it's because it's easy. The no, it's because it's not fast, okay? So being easy not means being fast, being something that you can print in 2 hours and then assembly it and start using it, okay? But even not being fast to build, like you will spend about 2 days printing and 1 more day assembling it, it's not complicated, especially because one of the most important things for me is designing a good project, but writing a good documentation. So you have a very, very well designed and revealed documentation and a video to help you, and a lot of tips to help you cut the way to have your MFS done and working for you. So, okay, what you are talking right now is that this is a project that a beginner could print and assembly, right? Yeah. Since this beginner is patient and love to build things, it will be easy for him or her to build this project. But on the other side, if you are not a very patient person or you doesn't like to build things or try to understand where to put a part and tight a screw or something like that, I don't recommend, because it has a lot of screws, it has a lot of parts that you will have to clean after printing and things like that. So be aware that this is a project for people that like to build projects. I know a beginner is able to build it because I have a lot of feedbacks, hundreds of feedbacks that people that bought the printer, received it in 1 day, and the next day start printing the MFS, and they are using MFS for a month now. So I know a beginner is able to print and assemble this project because we receive feedbacks from people around the world. There's both projects. We already sell it to all continents, including Greenland, Australia, United States, South America, China, Japan, and a lot of different countries. Was basically hundreds of projects like this sold around the world. And I like to thank you, all of you, for supporting our job here. And thank you for the awesome feedbacks you have been sending us through the email, through direct message on Instagram, and all the ways you found to send us messages to us. So thank you very much for your support. And this is the way I have to thank you, having new upgrades and a lot of improvements to make your life even easier with a new version of MFS. So talking about improvements, we have another special improvement for both of MFS projects. On the first version, we have this kind of adapter, which is an adapter with a kind of coils here to make it more stable when you put this on the filament spool. But this kind of adapter has one measurement for each kind of filament spool. And we know that around the world, we have a lot of different filament brands, and each one of them try to make different spools with different sizes, with different formats, and having one adapter or maybe 4 adapters of this type for each brand of filament we are using day by day, it's a kind of pain on that place, you know. So thinking on that, I've designed a new universal adapter to make our lives easier. Because I use MFS every single day here on the garage. So using this new adapter, you can basically use the same adapter on a lot of different type of spools with different sizes and formats. Even those spools that has a kind of retraction on the border, like the eSun filament spool, you can use this same adapter, or a very, very tight hole, you can use the same adapter. I have 2 different sizes of this adapter. One is this larger to use on larger filament spools, and we have a smaller one, a slightly smaller one, that can be used to enjoy the possibility of using 4 spools here. You can use this one, this a little bit smaller adapter. But just in case in your country you have a filament like this one that has a very, very big hole in the middle, I've designed a larger one that you can use on larger filament spools like this one, and have it stable to use in both actually MFS. You can use it on the K1 and K1C version and the K1 Max version. I do recommend you to print this one in Pat G because the ABS version was not very strong. The plastic doesn't have the right flexibility to handle the pressure of the spools. So all the versions that I've printed on Pat G are very, very strong and resistant, including it has a good resistance to a long-term pressure. So when you remove that from the spools, the coils here can get out back to the original position. I believe I said everything about the MFS project, but if you have any question, please get on the website inventorsgarage.shop. At the top, you will find a contact menu. Just click there, send us an email, and we will help you. We will answer any question you have. And I recommend you to ask all the questions you have before you buy the project, because my intention here, it's not force you or convince you to buy the project. My intention here is to show you what the project is capable of, and then you can make the decision of buying or not this project based on your needs. So one important thing here about the MFS project is that this project, it's not something that can resolve all the problems for all people. Okay, so if you have any question, please send us an email and we will help you the best way we can and orient you if the MFS is the right project or not for your needs. So our intentions here is to help you and not just sell you a project that maybe you will never use, or you can assemble that and this will not resolve the problem you are facing, okay? And as I said at the beginning of the video, if you live in a city or a region where you have the relative air humidity below 50%, the only reason to buy the MFS is because you like a lot to build projects, or you want to be able to handle the filaments from the front of your printer to save space or something like that in your farm. But below 50%, the MFS will not make that difference. Above that, until 75, 80%, the MFS will help you. Above 80% or 85% of relative humidity, I strongly recommend you the MFS, because for me here, living in a city that has between 85 and 95% of air humidity during the entire year, I can't live without the MFS anymore. So thank you very much for watching this video too here. And don't forget to leave your opinion here on the comments. If you have any question, I will be happy to answer you. And if you are a little bit shy, please send us an email through the inventorsgarage.shop, and we will be happy to answer you and to help you during your decision and during your building process. See you on the next video, and let's keep inventing.